Here's a quick one for you. This breakdown is brought to you by PA School. Please take me. It's an inside the park home run. As he rounds first base, we see his heart rate rise. This is compared to a flashback of him earlier in the game. Here are the numbers side by side. On the bottom, him sitting on the bench, kindly waiting his turn to play. On top, him running. His cardiac output, which is a product of his heart rate, how fast your heart's beating, and stroke volume, how much blood is pumped by the heart's ventricles during one cardiac cycle, all increases to match the demand during exercise. As a result of the heart pumping harder, blood pressure, the force of blood against the arterial walls, naturally increases, particularly systolic blood pressure, during the ventricular contraction of the heart. However, due to increased demand of blood by the body, vasodilation of his blood vessels occurs. Diastolic pressure should remain stable or even decrease. During an aerobic exercise, like running the bases, there is an increase to tidal volume, the amount of air that enters and leaves the lungs in each breath. As he rounds second, he's breathing faster and faster. This is to make up for your body's higher demand of oxygen intake and increased expelling of CO2. You see, the oxygen in the air moves through his lungs to the blood, where it is carried to the muscles that need it. This is called gas exchange, trading CO2 from the muscles for O2 in the blood. CO2 is a natural byproduct of the Krebs cycle, which is part of your muscle's energy creation and consumption. Similarly, there's a net production of H+, hydrogen ions, or protons, due to its presence as a byproduct of many steps of glycolysis, the breakdown of glucose into energy, which involves releasing a proton as ATP is broken down. To make up for this, the body uptakes H+, or protons, by using LDH, lactate dehydrogenase, in a reaction that combines pyruvate, NADH, and protons to form lactate and NAD+. As such, lactate concentration in the blood can be an indicator of exercise intensity and duration, as the body may prefer anaerobic metabolic reactions if the body's respiratory demands are not met during prolonged exertion. Although this plays more of a role in longer durations of exercise, not just rounding the base as fast as this guy can.